Okay, welcome to our next little lesson here as we work our way through the various review topics from multiple courses, but this one in particular is really just for those in Math 052 or 053. Those of you in Math 038 will not have to deal with the positive and negative numbers in the way that they will in the 05 level courses. Math 02 students, most of you are heading towards 052, so if you're interested in taking a look at this and seeing kind of where you're headed, there's just some basic addition, multiplication, subtraction, division that goes on here. Nothing that goes off your times table sheets. It's just that now we are considering positive and negative numbers, which is something you're going to be introduced to in Math 05 level courses. Negative numbers. Negative numbers in everyday life. Yeah, so you can't own a negative amount of something. Of course, you can't have like a negative number of marbles or a negative number of hot dogs. But it turns out in math that the use of negative numbers still comes in quite handy, and we even experience it in everyday life in a lot of different ways. Temperatures that are below freezing in Celsius, we call negatives. So on a really cold day, it might be, minus 12 degrees. When you spend more than you have in your bank account by accident, you will have a negative bank balance, and you'll probably have to pay some penalties or interest when that happens, assuming you have overdraft protection that allows you to go into the negative. And more in finances, accountants will enter negative numbers for refunds they receive, for example. In their expenses. So they buy something that's an expense, they enter it as a positive expense, but then if they return it and get refunded, it gets entered as a negative to counteract the first one and make it go away. So the best way to think about our positive and negative numbers is to always go back to thinking about the number line. So number line has 0 in the middle, as you can see there, and over to the right is all the positive numbers, and to the left is all the negative numbers. And we can see them counting up here and counting down over here, right? Bigger and bigger and bigger negative as we go to the left. Anything to the right on the number line, we consider anything. If you have two numbers on the number line, the one that is to the right is considered larger, and the one that is to the left is considered smaller, regardless of how big the actual number that goes with that positive or negative is. So, for example, 4 is larger than 1. Well, that's easy. We all already know that, right? There's 4. There's 1. 4 is to the right, so it's larger. But sometimes this next one throws people. 2 is larger than negative 3. Why? Because there's 2 on the number line, and there's negative 3. 2 is to the right of negative 3, therefore we call 2 the larger number. 0, how can 0 be bigger than anything? Well, it is. 0 is bigger than negative 2, for example, because 0 is to the right. 0 is bigger than any negative number. Negative 1 here is bigger than negative 4, because negative 1 is to the right on the number line. And there's how we could write that with our greater than signs. 4 is greater than 1, 2 is greater than negative 3, 0 is greater than negative 2, and negative 1 is greater than negative 4. We could also turn all those around. I just use the same numbers just for simplicity. 1 is smaller than 4, because 1 is to the left of 4. Negative 3 is smaller than positive 2. There's negative 3, smaller than positive 2, because negative 3 is to the left, and so on. Negative 2 is smaller than 0. Negative 4 is smaller than negative 1. And of course, we normally would say less than, so 1 is less than 4. Negative 2 is less than 0, and so on. So positive and negative numbers that of the same number, you notice, are an equal distance from 0 on either side. So there's positive 3, it's 3 to the right. There's negative 3, it's a distance of 3 to the left. And so what the negative sign actually is used in math to represent, what it really deep down represents is the opposite of. So positive 3 and negative 3. Negative 3 is the opposite of positive 3, because for positive 3, you go 3 to the right. For negative 3, you go 3 in the opposite direction to the left. It seems like a pretty simple idea, but they can make it very confusing with how they ask the question. So let's just quickly look at a few, starting easy. What is the opposite of 7? Now we know when we don't bother to write, this is one of those places where math people are lazy. When We decided that if we don't need to put the plus sign in front, we don't, but we know it's there. So that 7 is actually a positive 7. The opposite of positive 7 is negative 7. What is negative of negative 5? Well, let's look at that in pieces. That piece there, that says the opposite of positive 5, so that's negative 5. Then you stick another negative in front, and you're saying the opposite of that. So this is the opposite of negative 5, which is positive 5. So we see from that, if you have minus a negative or a negative of a negative, that actually becomes a positive, because what you're really saying is the opposite of a negative. So the opposite of negative 5 is positive 5. What is the opposite of negative 12? Well, the opposite of negative 12 is going to be positive 12. And again, you notice this is technically a positive 5 and a positive 12, but we're lazy and we don't write them there, even though we know they are there. And here's where they really convolute the language on you. What is the opposite of, remember that, the opposite of negative 20? Well, negative of negative 20 means the opposite of negative 20, which is 20, but they said, what is the opposite of that? So the opposite of positive 20 is negative 20, right? This is negative of negative becomes positive, so that's that thing there is positive 20, and they want the opposite of that, so it's negative 20. Okay, let's bring some variables in here, which they're very often going to do. So they ask us, what is the value of negative t when t equals 6 for part A or t equals negative 6 for part B? Whenever you sub in a variable, the first thing you want to do is you want to write, so we're evaluating negative t, that's the thing we want to figure out. And the first thing we want to do is replace that t with whatever its value is. And they've told us the value of t is 6. So what you do is use a bracket. It doesn't always matter, but in some cases it's really important. So always when you're subbing in that first step, put a bracket there. So you replace the t with a bracket. What goes into the bracket? The value of t, which is 6. Now this is a simple example, but they get more complicated. Get used to that habit of when you're subbing in a number for a variable, a number for a letter, start by replacing the letter with a bracket. So looking at that, well, in this case, the bracket actually isn't doing anything important. Negative bracket 6, that's just negative 6. So there's our answer. Over on this one, we're going to do the same thing. We want to evaluate what is the value of negative t. I replace the t with a bracket, and this time I'm going to sub in t equals negative 6. So the t gets replaced by a negative 6, and now we can see we have that situation we've already run into a couple times. The negative of a negative, in other words, the opposite of negative 6 is positive 6. And again, you see we're lazy. We know there's a plus in front of that 6, but we know we don't have to write it, and we still know it's there. Okay, now this, I can't stress this enough, and it's going to seem so ridiculously silly at the beginning, but this causes students more trouble down the road than almost anything else. And we are going to start to want to think about our adding and subtracting in a different way than you ever did before. And again, when people first see it and the examples are so simple, they think that's dumb. Okay, I'm just going to keep doing it the way I know how to do it. That will lead to problems for you. It will eventually get to the point where nothing is making sense when you think about it in the way that we first learned to think about this. So when we grew up and when we started going to school, we first think about adding and subtracting as something that's happening between two numbers. You're adding two numbers. 5 plus 2 is 7. 9 minus 3, you're subtracting two numbers. 9 minus 3 is 6. We want to change the way we think about those, and we want to think about them in terms of the number line. And again, we're not going to get into why this becomes important today, but later on it becomes really, really important. So we want to think of anything that's being added as going to the right on the number line, and anything that is negative being subtracted is going to the left on the number line. And we want to think about every piece as either having a plus or a minus in front of it. In other words, and I'm going to say this a lot over the next little while, this plus sign right here, that goes with the 2. It tells you that it's going to the right. That plus sign right there has nothing to do with the 5 that's in front of it. It's completely irrelevant. This minus sign here says that 3 is negative, it's going to the left. This minus sign has nothing to do with the 9. In fact, we know that that 9 is actually going to the right on the number line, right? It's a positive 9. So we want to stop thinking about adding and subtracting as something that's happening between two numbers, and we want to start thinking every piece has either a plus or a minus in front of it, and that tells you which way it goes on the number line. So that's what I think I'm going to describe here. So we have 5 plus 2. What we want to really think about is the fact that that 5, even though we're too lazy to write it down, actually has a plus sign in front of it. And that 9, even though we're too lazy to write it down, actually has a plus sign in front of it. So this says go 5 to the right, plus 5, and then another 2 to the right. And so we went a total of 7. So the answer is positive 7, and of course we can just write 7. This, however, says go 9 to the right, and then 3 to the left. And if you go 9 to the right and 3 to the left, you end up at 6 to the right of 0. In other words, positive 6, or we just say 6. And again, notice how this minus here had no impact whatsoever on the 9, right? The 9 is going to the right. The 3 is going to the left. The 9 is not affected by the thing after it, only by the thing in front of it. Again, that seems silly because you can just go 5 plus 2 and 9 minus 3 like you always did, but it will become more and more important to think about your equations this way. So here's a couple ones to try. Let's analyze each of these in terms of the number line. First of all, don't just start adding and subtracting. We want to determine if each piece makes us go to the right or the left on the number line. So that first one, we remind ourselves that the 4, even though we're lazy, has a plus in front of it. You don't need to always write this down. I'm just reminding you. You know it's there even if it's not written, right? So this says go 4 to the right, plus this says, well, that's the opposite, right? So that says go 12 to the left. 4 to the right and 12 to the left. If we go 4 to the right, 4 to the right of 0, and then 12 to the left, well, they're back 4 and another 8. We end up at negative 8. 4 to the right and 12 to the left. This says, and this is the one that starts to cause people a little bit of problem, because people will look at this all the time and say, oh, 3 plus 7 is 10. But no, this says go left 3 and right 7. 3 to the left, so let's start at 0. 1, 2, 3 to the left, and then 1, 2, 3, 4, 5, 6, 7 to the right. I end up at positive 4, not 10, not negative 10, not positive 10, but positive 4, right? Not 3 plus 7. 3 to the left, 7 to the right. The 3 has nothing to do with the plus sign behind it, only the negative sign in front of it that says go left for this one and right for this one. 2 minus negative 5. Well, I'm going to notice a couple things. First of all, I just remind myself that there's a plus in front of that 2, even though I don't write it. And then I have minus a negative, which we've already seen is actually plus, right? Opposite of opposite, opposite of opposite, negative of negative is a positive. So this actually says go 2 to the right and then another 5 to the right, which actually takes us to positive 7. And that looks confusing at first for some people because we're subtracting, right? There's this minus sign, but actually it's minus a negative, which says that this piece actually moves to the right. Don't even think about it as it's actually plus. Think about it as which direction, right? The 2 is moving to the right. The 5 minus a negative is also moving to the right. So they're moving in the same direction. 2 plus 5 is 7. Again, on this one, people will look at this and go 6 minus 3 is 3, but actually this says go 6 to the left and then another 3 to the left. Well, if I go 6 left and 3 more to the left, 6 to the left, 3 more to the left, I'm actually at negative 9. Again, you see how the way we used to think of this, of subtraction, starts to not work, right? You're thinking, well, it's 6 and 3, you subtract them, you should get 3, but we get negative 9 because the 6 is going to the left and the 3 is also going in the same direction. They are actually working together to go even further left. Yeah, so as we've been saying, every piece is controlled by the sign in front of it. The sign after it has no effect. There's a couple more if you want. You could pause the video and try those. We'll just carry on here for now, though. So again, people are tempted to go 6 plus 2 is 8, but actually that says 6 to the left and 2 to the right. 6 to the left takes us to negative 6, and then 2 back to the right takes us to negative 4. This says go 7 to the left, and then another 5 to the left. Even though it looks like subtraction, it's actually, don't think about it as a minus, right? Don't think about it as two things that are being subtracted. Think about it as every piece is controlled by the sign in front of it and nothing else. Left 7 and left 5 makes a total of left 12, negative 12. Also important little thing that will come up from time to time to be aware of is that 5 plus negative 3, what does that say? That says 5 to the right and 3 to the left, which is 5 to the right and 3 to the left, positive 2. This also says 5 to the right and 3 to the left is positive 2. Both of them say the same thing. So in other words, subtracting is actually just adding the negative. Subtracting and adding the negative are actually the same thing. They both say, in this case, go 5 to the right and 3 to the left. Okay, so this seems like a lot of work to try and think through that number line every time. So let's just try and make life a little bit easier for ourselves, because there's a bit of a shortcut you might have noticed. So the main question you want to ask yourself when you're adding and subtracting positive and negative numbers is, are the two pieces both moving in the same direction on the number line, or are they moving in opposite directions? So let's just look at these really simple examples. 3 plus 5, that says go 3 to the right and then another 5 to the right. Negative 3 minus 5 actually says go 3 to the left and then another 5 to the left. Now notice in both cases we get an answer of 8. It's just that one is positive and one is negative. In other words, in both cases we added, right? 3 plus 5 is 8. 3 plus 5 is 8. Why? Because they're both moving in the same direction. These ones are both moving right, so you add them together. These ones are both moving left. They're moving in the same direction, so 3 and another 5, add them together to get 8, but negative. So in both cases, we added 3 plus 5 to get the 8, and then the plus or minus is obvious. Are you moving right or are you moving left? Okay, so if the signs are the same, if they're both moving in the same direction on the number line, just add the numbers together. Whereas over here, if the signs are opposite, this one says right 3 and left 5. This one says left 3 and right 5. Right 3 and left 5. Right 3, left 5 is negative 2. Left 3 and right 5. Left 3, right 5 is positive 2. In both cases, we get 2. We subtracted 5 minus 3. You just got to figure out, did I go further to the left and get a negative answer? Or did I go further to the right and get a positive answer? So if the signs are opposite, we subtract 5 minus 3 to get 2, and then figure out if it's positive or negative depending on whether it went further right, the positive is bigger, or further left, the negative is bigger. So yeah, and here I've summarized that shortcut. If they're both moving in the same direction on the number line, you add the numbers, and then whichever direction they're going, left or right, makes it negative or positive. If they're moving in opposite directions on the number line, subtract the numbers and give it the sign of the bigger one that is controlling, that it went further in that direction. Why don't you pause the video right now and try a few of these on your own. Okay, let's look at these. So this says, let's see, let's not, this goes right off my number line, right? Plus I don't want to count out 42 to the left and so on. Let's use our shortcut. This says go 42 left, and this plus a negative says go 15 left. So these are both going in the same direction. They're both going left on the number line. So I'm going to add them together. They're both going to the left. 42 plus 15 is 57. So I went 57 to the left. That's my answer, negative 57. These ones are going in opposite directions. And again, this is the one most likely to cause people to make mistakes, because people look at this and they see 65 plus 8, but actually it's left 65 and right 8. So they're moving in opposite directions. So we subtract them. 65 minus 8 is 57. Which way did we go further? Did we go further to the right or to the left? We went further to the left, so it is negative 57. And over here, 32 minus negative. Okay, as soon as we see minus negative, we know that is actually positive, because it's the opposite of moving to the left, right? Minus, opposite of moving to the left. So this is 32 plus 24. Those are both moving in the same direction to the right, so we add them together and get positive 56, or just 56. Positive because they're moving to the right. Okay, on to multiplying and dividing, which actually is way easier than the adding and subtracting. There's just one simple rule you follow for multiplying and dividing. If both of the numbers have the same sign, then the answer is positive. If they have opposite signs, the answer is negative. Don't confuse this with your adding and subtracting rule, where you have to think about the number line. This is just a straight rule to follow. So let's look at the 4 options, Sarah, for the multiplying. These are all 7 times 3. All 4 of the answers are going to be 21. It's just a matter of if they're plus or minus. If positive times a positive, the signs are the same, so we get a positive answer. Positive times a negative, the signs are opposite, so we get a negative answer. Negative times a positive, the signs are opposite, so we get a negative answer. And negative times a negative, the signs are opposite, so we get a positive answer. And there down below, I've listed just because multiplication we can write in so many different ways, right? We can use the dot, or we can put them in brackets with the dot, or we can use the times sign, or we can just write a number in front of a bracket is also another way to write multiplication. We can put a dot and a bracket, write all kinds of options. We can put them both in a bracket, and that's also multiplication, and there's more. And same, so I've just listed a bunch there just to remind you there's a whole bunch of different ways to write multiplication. So if they have the same sign, both positive or both negative, when they're multiplied, you get a positive answer. If they have opposite signs, you get a negative answer. Dividing is the same. These are all 20 divided by 5. They're all going to give you an answer of 4. But if the signs are the same, so both positive, we get a positive 4. But if the signs are opposite, one positive and one negative, we get a negative answer. Here in this last one, a negative and a negative being divided, the signs are the same, we get a positive answer. And again, there's a bunch of ways we can write division. We can write division we know as a fraction. 20 divided by 5 is the same as 20 over 5. We can throw in unnecessary brackets, 20 in bracket divided by 5 in bracket, or just one of them in a bracket. There's multiple ways that all mean the same thing, division. Okay, so we're going to go back to order of operations. So we did that this last week, and that is BEDMAS, brackets, exponents, division and multiplication together, addition and subtraction together. When you have positive and negative numbers, you still have to follow your order of operations. So here we have, let's see, negative 5 plus 2 times negative 3. I jumped ahead there. So any brackets? No. Now this looks like a bracket, but remember what the brackets in BEDMAS actually means is when there's something to work out inside a bracket. That bracket is a negative 3. There is nothing to work out inside that bracket. It's already done. Any exponents? No. Division or multiplication? Yes. Multiplication. 2 times negative 3, so we're going to do that first. Positive times a negative is a negative. So 2 times negative 3 is negative 6. That's all the division and multiplication. So finally, addition and subtraction. Yes, now we got to be careful. This says go left 5. And that says go left 6. So they're going in the same direction. We're going to add them together. 5 plus 6 is 11. To the left, negative 11. Over here, let's see. Brackets that have to be worked out. Yes, in this case, 2 minus 5. So 2 minus 5 becomes negative 3. That's 2 to the right and 5 to the left, right? So moving in opposite directions. Any exponents to work out? Yes, this says negative 3 squared. Reminder, that means negative 3 times itself. Negative times a negative, that is actually a positive. Negative 3 squared is positive 9. So the negative 3 squared becomes positive 9. Now I got a division, a negative divided by a positive. So 90 divided by 9 is 10. A negative divided by a positive will be a negative answer. So order of operations, which we already knew, but now with positive and negative numbers coming up there. So you have to be very careful with your adding and subtracting rules. Think about the number line, and your multiplying and dividing rule. If they're the same, it's positive. If they're opposite, it's negative. Let's try it. Why don't you take a moment and try these ones yourself? They get a little bit more involved. Okay, on that first one, do we have brackets? Yes, we do. A bracket to work out, 3 minus 7, so that's 3 to the right, 7 to the left. So they're moving in opposite directions, so subtract, that's negative 4, because we moved further to the left. And now, do we have exponents? Yes, we do. Negative 4 squared. Remember, a negative times a negative. So negative 4 squared means negative 4 times negative 4, which is positive 16, because it's a negative times a negative. There's the exponents. Do we have division and multiplication? Yes, we do. Remember, division and multiplication are equal. We work them out from left to right. In this case, there's just the one multiplication, 2 times 16, 32. And finally, do we have addition and subtraction? Well, yeah, that's all that's left there. 5 to the left, 32 to the right. So they're moving in opposite directions. Subtract them and get 27. Did we go further left or further right? We went further right. So positive 27, and that's our answer. Next one, are there brackets? Yes, there's a bracket to work out. There's also this bracket out here, which doesn't do anything. There's nothing to work out in that bracket, so that does not actually fall under the brackets category, but 6 to the left and 9 to the right means 3 to the right. We combine those. Now, are there exponents? Oh yeah, we already talked about that. There's nothing to work out inside that bracket, so that's actually not part of the bracket step. No exponents. What about division and multiplication? Yeah. So I got this 8 minus out here, but that's addition subtraction, so that nothing's happening with that yet. I got division and multiplication. Remember, division and multiplication are tied. We do them in the same step from the left to the right. So 15 divided by 3 first. Yeah, we do it left to the right, yeah. Oh yeah, some people will see these brackets. We already talked about this a bit, and they think, oh, I guess I do that first because they're brackets. But no, the brackets in this case aren't representing something inside there to be worked out. They're just holding those numbers inside them, right? So that's not what the B means. The B means when there's something to work out inside a bracket. All right, so 15 divided by 3 is 5. And then 5 times negative 4 is negative 20. So there's my division and multiplication worked out left to right. Now minus a negative we know is plus. So 8 plus 20 That's 8 to the right and 20 more to the right. 28.